Now let's conduct a Gage R&R study on the rubber band data. Here's our worksheet with our rubber band information. And we had a small rubber band, a medium-sized rubber band, and a large rubber band. We had Chuck as an operator, we had Jan, and we had Tom. And the distances that were measured based on the particular rubber band are recorded in the distance column. Let's click on the big blue eye and get information. We can see that we've got 90 data points, none missing, and with 3 operators, that would be 30 data points for each one, and a repetition of 10 samples for each of the 3 different parts. Alright, so they each shot small, medium, and large 10 times and captured the results. Alright, well, let's take a look at our Gage R&R analysis, and we'll start by clicking on the Stat pull-down menu. We'll go down to Quality Tools. We're going to select a gauge study, and it's going to be Gage R&R study crossed. So we're going to perform a Gage R&R study with cross designs. Alright, for the part number, we're going to select part. For the operator, C3 is operator, and the measurement data is the distance. The gauge info. The gauge name is tape measure. The data study today, reported by yours truly. And miscellaneous, we're going to say rubber bands. From an option standpoint, we don't have any specifications associated with how far they should travel, so we're not going to put any of that information in there. And we can give a title to this one, and this is our rubber band exercise. And now let's generate our graph. So here we have our output from the rubber band study. Notice that when I hover over these, all right, 99.4%. We're really explaining a lot of the variability in the part-to-part differences there. That's good. And we're seeing very little contribution from our total gauge R&R, our reproducibility, or our repeatability. Notice that our operators are all well within the control limits on the range. And notice that we have very tight control limits, and none of the data points fall within those as far as our R chart is concerned. Our X bar chart. That's exactly what we want to see. And let's see, distance by part. We can see that the box plots are very, very narrow. It looks like each one of our box plots for our operators looks about identical, and I don't really see much difference in our charting of the interaction between the operators and the parts. So this looks to be one heck of a good Gage R&R study, and it looks like that tape measure was probably adequate for figuring out the distance that rubber bands travel when stretched 1 inch and fired from a horizontal position off of a ruler. Something that I'm sure you're going to be doing in business all the time. Let's click on the session window and let's scroll up a little bit, and we can see here's our analysis of variance, and we can see that the part has a p-value that's much, 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 much less than 0.05. Which means that there is absolutely differences between a small, a medium, and a large rubber band. Operator coming in at a whopping p-value of 0.658. Is that bigger than 0.05? Absolutely. It's hugely bigger than 0.05, which means that there's no differences between our operators, which is exactly what we wanted to see. Differences in the parts, but our operators can't tell the difference at all. Perfect. Let's look at our variable percent contribution. It should be less than 9%. Anything less than 1% is fabulous. Well, we're at 1.13%. That's pretty darn good for a gauge. And our percent study variation. We would like this to be around 10%, and it is around 10%. Is it much less than 30%? Yes. Is it less than 20%? Yes. It's hovering right at that 10% range. So that's great. We've got a terrific gauge, and we can measure the distance that rubber bands travel with repeatability and reproducibility and confidence that our numbers are going to be accurate using our tape measure. So there you have it. That's Gage R&R on continuous data in Minitab.